friends, so now we are starting the fifth part of the chapter determinant. In this part 5, the content we are including theorems on adjoint and inverse of a matrix. Some good questions, objective type questions based on these theorems. Theorem number 1 is A into adjoint A equals to adjoint A into A equals to determinant A value into I. Its proof is not in our course, so we can learn the theorem A into adjoint A equal to adjoint A into A equals to determinant value of A into I. Second theorem is A and B are non-singular matrices. What is singular matrix and what is non-singular matrix? If a matrix determinant value is 0, then it is said to be singular. And if determinant value non-zero, then it is said to be non-singular. That's why A and B are non-singular matrices of same order. Then AB and BA are also non-singular matrices of the same order. Third theorem is product of two, say AB, and we want to calculate its determinant value. It means the separate product of determinant A into determinant B. Important proof: adjoint of A equals to determinant value A into I, we know using this theorem number 1. It means determinant A into I means determinant A is just like a number 2, 3, 4, 5, 15. If we multiply with identity matrix, it will become a scalar matrix. So this is scalar matrix A, determinant inside, inside and inside. Now if you take both the side determinant, convert this one in determinant, we can write like this, equal to this matrix is converted into determinant. Now first row determinant A out, second row the same out, and third row again the same out. It means we are getting determinant value A, the cube, into I. This side is adjoint A into A. We can divide by this theorem in two separate determinants. So one power is cancelled out with this 3. Here it is 2. Most important theorem that whenever we want the determinant value of adjoint A, then it is of 1 less that order. Here we are taking order 3. That's why we are getting determinant value A square. Suppose it is already with 2 by 2. Then here we write adjoint of A of 2 by 2 determinant value is only determinant value A. If it is of the 4th order, then we have to write adjoint A determinant value equals to determinant A value power 3. So very important rule that whatever be the order of the matrix, 1 less power value to the determinant will get the answer. Is a good objective question actually. Now the next and the final 4th theorem is theorem number 4 is a square matrix A is invertible if and only if A is non-singular. How we get the inverse? Suppose we have A and B are two square matrices and their product equals to I. We want to prove that A is the inverse of B or B is the inverse of A. If we take modulus on both the sides, A into adjoint A into A equals to this one. Suppose we divide the whole by determinant A value, then what we are getting? A into adjoint of A divided by determinant A adjoint of A divided by determinant A equals to I. It means this is the separate B matrix, this is the separate A into B equals to B into A. A into B equals to B into A equals to I, which we have already completed for these square matrices. A is the inverse of B and B is the inverse of A. It means if it is AB, if it is BA, the meaning is B is the inverse of A or A is the inverse of B. Here we want to calculate inverse of A. So inverse of A we can write adjoint of A divided by determinant value of A. This formula we can use in many questions to calculate A inverse. Now, some problems based on adjoint and inverse, say exercise number 4.5 and question number, write down, say question number 14th or 13th, first 13th, page number 132. If A equals to a 2 by 2 matrix 3 1 minus 1 2, then prove that A square minus 5A plus 7I equal to null matrix, and hence find A inverse. The important line is, using this you have to calculate A inverse. So first thing, we have to calculate A square, revision of the product of two matrices. This matrix is of order 2 by 2. We want to calculate A square. It means we have to write the first matrix 2 times with proper space. Why? Because the second matrix having 2 columns. My method is number of times the columns in the second one, we have to write the first matrix with proper space 2 times, because 2 columns. First number is 3, multiplying by 3, down minus 1, up 1 and 2. This is the first tower, is the second tower, and is the complete society. Total 9 minus 1 8, minus 3 minus 2 minus 5, 3 and 2 5, minus 1 and 4 3 is the value of A square. Clear? Minus 5A. So 5A value is, you have to write 5 times. 5 times is the value of 5A. And the last 7I. 7I means only diagonal 7 7, other numbers zeros. So we have all the 3 things. First A square with us, 5A with us, 7I with us. Now we want to make A square minus 5A plus 7I. So 8 minus 15 plus 7. 5 minus 5 plus 0. Minus 5 minus plus 5 and 0. Last 3 minus 10 plus 7. Totally, what we are getting? 0, 0, 0 and 0. It means it is proved that the value of A square minus 5A plus 7I equals to null matrix, that is all elements belongs to this matrix 0 0 0. Now the important part starts from here. After solving this, we want to get the value of A inverse using this equation is the important part. So now how we solve? Sometime the student get the answer of A inverse by again getting the method like adjoint and determinant A value. No. In this question it is very clear. Using this equation we have to find A inverse. And some more problems 15th and 16th also based on the same concept. So here A square we can write as A into A. We can write this minus 7I on right hand side. Now if we multiply both the side by A inverse, multiplying by both the side by A inverse. This will become I. I into A will become again A. 5 A inverse A will become 5I. So this is 5I. And this is nothing but minus 7, and A inverse into I is again A inverse. So if I want to calculate A inverse, I have to divide this whole by minus 7. So here we can write A minus 5I, and outside we have to write minus 1 by 7. How we calculate A minus 5I? Very simple thing. A and minus 5I. So what is 5I? 5I is nothing but this is 5I. Now what we want? We want A minus 5I. So 3 minus 5. 1 minus 0. Minus 1 minus. And 2 minus 5. A minus 5I divided by minus 7 is A inverse. It means the final answer A inverse equals to minus 2 by 7 means 2 by 7, minus 1 by 7, 1 by 7 and 3 by 7 is the answer for A inverse. I think the important point, hence find A inverse. Using this equation, don't calculate directly by adjoint or A. So this type of questions in your exercise number 5th, 4.5, question number say 14th, 15th, 16th, all these questions based on this type of, sometimes it may be A cube. So you have to calculate A square into again A. And if it is 3 by 3, it is very lengthy. But the marks also carrying maybe 4 or 5, 4 or 6. So this topic, I think, very important topic, especially for competitive exams, objective type questions, we have to use different 4 theorems. And for the CBSE subjective questions, this type of 13, 14, 15, 16 questions are very important. So in our next topic, we'll learn solution of equations, linear equations. Tab tak.